In this video, I explain what is meant by the trigonometric ratios, or the three common ones anyway, which are sine, cosine, and tangent. But before we talk about those in turn, let's think about some terminology. If I have a right-angled triangle and I focus on an angle here, we often, when we focus on an angle or talk about an angle in trigonometry, use the Greek letter theta. That's the way we write it, theta. And then, given that, we label the sides. Now, as usual, in a right-angled triangle, the side opposite the right angle is called the hypotenuse. Let's abbreviate it to H. Now, the side which is opposite to theta over here, we label the opposite. Let's abbreviate it to O. And the last side, the one which is alongside theta, we call the adjacent. Let's abbreviate it as A. Now, just to make this a little bit clearer, in this triangle, let's say we're focusing on this angle up here, then clearly the side over here is still the hypotenuse, labelled H, but now, because we're focusing on this angle, the side opposite theta is this one. The side adjacent to theta, the one alongside it, is this one. So there's some terminology that we use when we focus on an angle in a right-angled triangle. Now we can talk about the three main ratios. First one I'm going to consider is the sine ratio. It's the name given to the ratio, or when we divide the opposite by the hypotenuse. You'll notice I haven't labelled the adjacent here. It's of no interest to us when we're talking about the sine. The sine of this angle is the opposite divided by the hypotenuse. You see, it doesn't matter what size triangle we have, providing it's got 21 degrees in it, say as an example, the opposite divided by the hypotenuse will always be the same number. If you divide 1.8 by 5.2, you get 0.35. In this bigger triangle, if you divide the opposite by the hypotenuse, 4 divided by 11, you get 0.36, pretty much the same, just a rounding error there. Now, because it doesn't matter what size the triangle is, you always get the same answer for 21 degrees. This is pretty special. It's called the sine of 21 will always have about this number. And therefore, you used to be able to look these things up in a book. Sine of 21 you could look up in a book and it'd be around about 0.36. Now, you don't have to look it up in the book though. I don't have to look it up in the book anymore. We can now use our calculator. If you hit sine 21 on your calculator, round it up to two figures, you see it's 0.36. So what this means is it doesn't matter what size a triangle is, as long as it's right angled, as long as it has an angle of 21 degrees, the opposite divided by the hypotenuse will be 0.36. That is called the sine of 21. So for a general angle theta, the ratio of opposite over hypotenuse, opposite divided by hypotenuse, is called the sine of that angle. Sine theta is opposite over hypotenuse. And notice when we're writing this, we drop the E. It's abbreviated to sin. Sine theta or sin theta is opposite over hypotenuse. Now what about cosine? Now you notice all I've done is labelled the adjacent and the hypotenuse. The adjacent divided by the hypotenuse is called the cosine of the particular angle. And again, it doesn't matter what size the triangle is. As an example, for 21 degrees, the adjacent divided by the hypotenuse should be the same number. Let's see what we get. Adjacent over hypotenuse here is 0.94. Adjacent divided hypotenuse here is 0.94, the same. The adjacent divided by the hypotenuse is called the cosine. So the cosine of 21 degrees is about 0.94. We could check that on our calculator. And we get on the calculator if you round up 0.93, pretty close to these, just some rounding errors involved there. So in summary, for any angle, the adjacent divided by the hypotenuse is called the cosine of that angle, or shortened to cos theta, is adjacent over hypotenuse. And the last ratio, here the only sides of interest are the opposite and the adjacent. opposite divided by the adjacent is called the tangent of that angle. So 1.8 divided by 4.9 for 21 degrees, it's 0.37. Opposite over adjacent for this bigger triangle is 0.39. A little bit of error there. That is called the tangent of the angle 21 degrees. We could look it up on our calculator and see that it's 0.38. Doesn't matter what size the triangle is, providing it has an angle of 21 degrees in a right angled triangle, the opposite of the adjacent will be about 0.38. So in general, the tangent of theta, the opposite of the adjacent, we abbreviate to be tan theta, is opposite over adjacent. So there's our three common ratios. So let's summarize that. In a right angled triangle, if we have a fixed angle theta that we're focusing on, the opposite divided by the hypotenuse will always be the same number, which we summarize as the sine, or we call the sine ratio. So the sine of the angle theta is opposite over hypotenuse. For a given angle theta in a right angled triangle, the adjacent over the hypotenuse would always be the same number, which we summarize or call the cosine ratio. And lastly, for the given angle theta, the opposite over the adjacent would also be the same number for the given angle theta, and that's called the tangent ratio. So we need to try and remember these. So if we write it down like this, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. If we say this over to ourselves, SOHCAHTOA. If you say that enough times, SOHCAHTOA, SOHCAHTOA, you will remember it. And we should be writing that at the top of our page whenever we do exercises or when we do a test. That's one way to remember it, just as this strange word, SOHCAHTOA. There is another way, and you can perhaps make up your own. But here's the way I was told. Some old hags, which comes from the sine ratio, cannot always hide, cosine ratio, their old age, the tan ratio. So in future videos, we'll learn how to use these ratios to solve for unknown sides and angles in a triangle, or a right angled triangle at least.